Hello guys, in this video I will be showing you how to create a Windows cluster and SQL Server failover cluster instance using Windows Server 2016 Data Center Edition. And upon this we will be in this cluster we will be using always on availability group to create a disaster recovery scenario. So we will have ultimately an environment with 2-node Windows cluster hosting SQL Server failover cluster instance and 1 DR machine, and we will be using one test database to failover between high availability and availability groups as well. So as of now we have 3 machines available, which is first is SQL node 1, second one is SQL node 2, and third one is SQL VR1. So for this lab I will be using just small machines like 2 GB RAM and 1 core machine. We have already set up a domain for this, and all these 3 machines have already joined to the domain. All these IPs are already mentioned here, so that we should be aware about the details and maps for all the IPs. These 3 IPs have already been assigned, so we'll be creating a new cluster and obviously SQL Server failover cluster instance and a listener for availability group as well. So to start with, first thing we have to enable the Windows Server failover cluster feature. This feature, we'll just go to add features in server roles. We'll enable this feature on all the machines. This will help us in creating a cluster and adding these nodes to the cluster. So for creating any cluster we have to have this feature available, plus once we add these nodes to any existing cluster, the feature should be available as well. Okay, so installation has been succeeded on the first node, so I will just verify the cluster disks which already have been available to these machines. Okay, and this is completed on second node as well. I will verify the disks available here as well. Okay, this is in progress. So we have already allocated shared storage to these 2 machines using iSCSI feature. So ideally we should have 4 disks available for these 2 machines. First disk is 10 GB. It is available, it is allocated for SQL Server installation. The second one is 5 GB, it is for temp DB, and third one is for data, and fourth one is for log. This is just for sample because we have to just create a sample database. So in production environment we have to allocate the temp DB, data file, log file and master system database accordingly and as per our requirement. So we will initialize these 4 disks using GPT. MBR is also feasible for this lab, but just to have good practice we'll be using GPT. MBR is the old format for the disks, and the limitation for MBR is 3.5 something terabyte, so we'll be using GPT. Okay, so here we will be keeping these disks as offline because these are shared disks, so we will not touch these on all the nodes. I will just start allocating the disks. For SQL Server, as you know, as a best practice, we have to use 64-bit 64K allocation units. We'll be naming this as SQLite 1 as master for system databases. Second disk will be for the temp DB. Okay, so disk formation is completed. We will just keep them as offline so that we can perform the disk storage test while creating the SQL Server, while creating the Windows cluster in fact. So I will just keep them offline and then we will move forward for creating the actual cluster. So for the cluster creation, we have to have an account which should have create computer objects in Active Directory. It should have the rights to create computer objects in the Active Directory. So for this lab, I'll be using domain administrator, but obviously in the production systems, you have to use a regular account which should have only the permission to create computer objects. So all these disks are now offline. We'll just start Windows Server Manager and we will open up the failover cluster instance, failover cluster manager. In failover cluster manager, we will be adding these two nodes in the cluster to form a Windows cluster. For that, there will be some tests need to be performed. All these tests should be successful so that Microsoft can actually support this. So failover cluster manager is started now. We will just create a cluster. For this we will have to have the name of the nodes available, so we'll be using these two nodes, SQL node 1 and SQL. So if these machines are successfully joined to this domain, they will recognize this, all these machines, and we have to then go further for performing the validation tests. So we must perform all these tests to be able to make sure that the cluster we will be creating is in a healthy state. So all these tests, we will keep it as it is and it should be successful. So this will take some time to run. Okay, so the validation has been completed. So far the tests are successful. We will be having only one warning, which is related to the network cards. As we can see that we only have one card available, network adapter, which is a single point of failure. So this is actually mentioned here in the warning. We can see that this node is only accessible by one pair of network interface. So this is a single point of failure. This is just a warning. So ideally in production environment we will be having multiple network cards and this warning should not appear. So as of now we will just ignore this warning and proceed for actual cluster creation. So for this cluster we'll be using the cluster name as when CLU01 and when CLU01 and the IP should be 11. And if this account has the create computer object rights, then it will be successfully creating this DNS record for the cluster. Lastly, we will add all eligible storage to this cluster. Eligible storage means the shared storage which is attached to these nodes. So we'll press next and proceed for actually creating the cluster. Okay, so cluster has been created. We'll just click finish and we will see the current state for this cluster now. It is a 2-node cluster. We'll just verify that all these disks are available. The first disk, it should be available for log. As of now it is attached as the disk witness. So we'll just remove this disk from the quorum. Advanced, we will just keep the 2-node as the witness, as the votes, and there will be no witness for the quorum. So now there is no role, 2 nodes and 4 disks. So to start next with the creation of SQL Server cluster, first we have to create a new role. We'll just assign a name to this role like SQL 1 and make sure all these nodes are mapped to this role, and all these disks should be assigned to this role. So we will assign this disk to the role, and as of now we have only one role created. So once we have this role available with all the storage, then we can start actual SQL Server cluster installation. Now all these disks, all these resources are mapped to a single role, and in the resources for this role we can see all these disks are now available. So this is now a healthy Windows Server cluster. We can test to failover this role to another node. We'll see this node. As of now there is no storage available. We will failover this SQL 1 role from SQL node 1 to SQL node 2, and all these storage should be available here. So the initial test is successful. We will just fail back this SQL 1 role to SQL node 1, and we will start our installation for SQL Server. For this video I'll be using SQL Server 2017 installation. And there is only one role, SQL 1, which is mapped to this cluster. We will use new SQL Server failover cluster installation, and we will pass all the roles now. Okay, everything is successful, just there are some warnings. These are the same warnings which we have already seen in the cluster, so we will just ignore this. For this installation we'll be just installing the SQL Server engine. using named instance, and there will be a network name for this. So network name is SQL Live 1DB. SQL Live 1DB, and SQL Live 1DB will be the actual cluster name, is the network name as well. Here all the roles will be available. We have seen this role here in the Windows cluster. So this role is now available to Windows installation. We will just select the SQL Live 1 role and press next. All the storage available will be shown here. So in the production environment, if you have more than 4 disks available, so all the storage will be listed here. So you have to map all these disks like disk 1, 2, 3, 4. Make sure that all the disks available for this particular role are selected here. There might be multiple more disks available here. So you have to select only those disks which are available for specific this role in which you are going to install the SQL Server failover cluster. Here we will assign the IP for this SQL Server network name. We have chosen SQL Live 1DB and the IP is 192.168.255.14. Again, this installation will also use the permissions to create computer objects, which will be the DNS entry for SQL Server cluster. As of now, I am using the domain admin, although in the production system we should have the SQL Server service accounts available with the lowest possible permissions, and we should only use those specific SQL Server service accounts. Assign the password to SA, and for data directories we will be using the appropriate data directories. For master, we'll be using master DB folder. For tempdb, we will create another folder as tempdb. For data, we'll be creating another folder data, and for log, we'll be using log folder. Now we will map all these to the appropriate folders. MasterDB, this will actually host all the system databases. UserDB, it will host MDF file or NDF file for user databases. Log folder will be hosting the logs, LDF files, and as of now we'll just use the same data folder for backups. In the production environment, you should use a separate folder or a network drive for the backups. We will also map tempdb folder as well. Also mapped, and as of now, as this is a test environment, we will not be using file stream. So this will take some time, and now the installation should be succeeding. Okay, so installation has been successful now. So we will close this installation on this node and start the add node installation on the other one. So in this node there will be a small installation required just to add this node to the existing SQL Server failover cluster instance. And in the first node we will be able to see this role will be used to create the cluster. And in the second node we will be able to see this role will be used to create the cluster. And in the third node we will be able to see this role will be used to create the cluster. And in the fourth node we will be able to see this role will be used to create the cluster. And in the fifth node we will be able to see this role will be used to create the cluster. And in the sixth node we will be able to see this role will be used to create the cluster. And in the seventh node we will be able to see this role will be used to create the cluster. And in the eighth node we will be able to see this role will be used to create the cluster. And in the ninth node we will be able to see this role will be used to create the cluster. And in the 10th node we will be able to see this role will be used to create the cluster. And in the 11th node we will be able to see this role will be used to create the cluster. And in the 12th node we will be able to see this role will be used to create the cluster. And in the 13th node we will be able to see this role will be used to create the cluster. And in the 14th node will be having SQL Server instance, agent, and other features. Also, the network name should be available here. As of now, this cluster is only capable of being online on one node. Once this is installation is completed on the other node, then it will be able to fail over and fail back as a highly available cluster. So in this installation, we will be using add node to a SQL Server failover cluster. You can ignore this warning. This is the same warning. So it is showing that as of now there is only one role available, which is already added to one node, and this will be adding another node, SQL node 2, to this cluster. We'll just have to verify the network configuration. As of now we cannot change it, and we'll just enter the service account credentials, and that would be all. So meanwhile the installation is in progress. We will just start installation for SQL Server Management Studio, because we know that in SQL Server 2017 the Management Studio does not come with the installation, so we have to install separately SSMS. Ideally on the production system we should install SQL Server Management Studio, but for this lab I'll be using the same machine. Okay, so installation is completed now. We can open the failover cluster manager on this node to see if we can easily failover and fail back this SQL Server cluster or not. So as of now we can see that there are no storage available here. So SQL Server SQL node 1 role will be hosted on the first node. We will just review this, that resources are available here. Okay, perfectly fine. Now we will just move this node, this role, from the first node to the second one, and ideally this should come up within less than a minute from SQL node 1 to SQL node. Okay, perfect. So test is successful. So now we'll be moving towards creating the always on availability groups. For that obviously we need the SQL Server Management Studio. We will just wait for this installation to be completed. Meanwhile we will start installation for SSMS on the other node as well. Okay, so SQL Server Management Studio installation is completed. We will just close everything else, because this machine has only 2 GB memory, so I will close everything else and open up the Management Studio. We will just restart this machine. I'm not able to actually open up anything related to SQL Server. Okay, so restart has been completed. I will just pin this to the taskbar. Hopefully this will open perfectly fine. Okay, got it. We will just connect here and also make sure that just so that if we can change the port for the SQL Server listening as well. Okay, the dynamic ports are enabled. We will just use this custom port 1426. Also on the second node we will change these settings. Okay, so we have restarted the SQL Server engine as well, and now we should be able to connect using the port, which is the new one, 1426. And next thing, we have to enable SQL Server always on feature. This again requires a restart, so we will just restart this instance. So for always on availability groups, we have to first create an availability group, and it will be, the name of this group will be, for example, AG1. It should be async as of now, manual, and secondary replica should be readable. We are creating always on with for the purpose of high availability. Obviously we have to make sure it is in the sync mode with automatic failover, but for the disaster recovery scenario we must use async and manual failover. So we will just create OK availability group and click OK. Now it should be available here, and we will only see one replica. In the failover cluster instance, we will see that now we have another role created by always on with the name of AG. As of now there is no listener, so we will create a listener as well. We'll use the name SQL Live1 list. SQL Live1 list, and the port is 1426, IP is 192.168.255 and 16. Press OK and press OK. And in failover cluster manager, the role is also assigned with SQL Live1 list and the IP. So now we should be able to connect with this instance with the listener name. As we have the custom port, so we'll use the custom port as well. So you can see now we have this listener available, but the instance name is the primary one. Now we will proceed for installing SQL Server on the third node in fact, which will be used as a DR replica. So keep in mind that previously we have used for the cluster installation the installation as clustered installation. For the always on availability groups we have to use a standalone installation, and the storage available should be local available storage. So as of now we can see that we have 30 GB available, and that would be sufficient for the lab, although in the production system we should have local storage available. So before starting this installation, we should just make sure that this node is added to the cluster. As of now it is not added, so we will just add it. Again, we have to perform all the tests, so it will take some time. Meanwhile, we will just create a sample database in the primary node so that we can actually perform a failover and failback test. The database has been created. We'll just verify it should be in a full database recovery mode. Okay, so recovery model is full, which is good. We will just take a full and log backup of this database so that we can add this database to the availability group. As we know that for any database to be available in the availability groups, the database should be in full recovery model. Plus, to add this database to the secondary replicas, we should manually backup and restore the database from the primary site to secondary replica. This is just one option, although we have multiple options for syncing. There are several ways we can automatically sync that, but that is an advanced configuration and we will cover that in a separate video. Okay, so for the failover cluster validation tests, the third node has passed everything. We will just uncheck all eligible storage for the cluster, although there is no storage available which is eligible for this cluster. We will just add this node and ideally it should be available now. Okay. We will also just back up the database, full backup and log backup in a single file. File is available here. We will just open the other node. Just make sure it is accessible from here. Now we will start the standalone installation on the DR node. It is new SQL Server standalone installation. These are pretty much same steps, but we will not be having the cluster role and the disks available for that. Rest everything I will be using a single folder which I will create now on the C drive. Okay, so the installation is now complete. We will just make sure that the ports are updated accordingly. I'll be using the 1426 port. Enable always on feature as well, obviously. Just restart the SQL Server service and it should be available to be added on the primary site. I will just copy this backup in the directory which is available here. Okay. From the primary site. I will be using the SSMS to connect to this node. SQL DR1 so /SQL. Okay, it is available now. I will open up first availability group, add the replica. So the endpoints are missing. We will just create an endpoint for this. Okay, so we'll be creating endpoint now. Just refresh and this should be good now. Okay, so now we have endpoints available here as well. Yep. Now we just want to make sure that we have manually done the backup and restore. We will just join this replica to the availability group. Okay, so there was one point missing, that we have to use the domain account for SQL Server installation on the DR node as well, which was skipped. So I just used that account and rerun the add node, and it was successful now. So we have to use the service account appropriately so that we have a healthy system. Now we will just add one database. The backups are available on the DR node. We will just restore these backups. Make sure that we have full and log backups available. Files should be appropriate in the appropriate location, and make sure it is in the no recovery model. Sorry, in the no recovery state. So the database will be in a restoring state. Now the database should be able to be added here in the availability groups. Okay, it should meet the requirement. Until let's just select this database, connect to DR, just join, and that would be all. Just refresh the dashboard, it should be available now. So now we will see the state of the availability group at primary instance, the DR instance, and the listener state. So the listener will always be primary, it is synchronized. Okay, DR state is secondary, and it is also synchronizing because it is in async mode. And the primary side is also primary and in synchronized mode. We'll just start a quick failover test. As of now it is in async mode, so data loss will be there. We'll just switch from async mode to sync mode. And then do the failover. Okay, now there is no data loss, it is green. It should be able to failover from primary side to DR side. And that would be successful from shifting from primary side to DR side. Now we should know that the DR side will be primary, the primary site will be actually secondary, and the listener, we will see that now this listener is hosted on SQL DR site. We will fail back this site again, make sure it is available. DR failover and failback, they are very quick and always on. Now the listener, it will show us the primary site. So here we can see that using one database and 3 node, we have deployed successfully high availability and disaster recovery scenarios. And just for the best practices, we will make sure that the availability group, as this is being used in the DR scenario, it should be in async mode for normal operations. So that would be all. Thank you very much for watching. Bye bye.